Hey, what's going on, guys? In this video we are going to talk about number systems. Particularly we are going to talk about hexadecimal and octal. Now let's look at the hexadecimal first. When we talk about hexadecimal, that is base 16. So there are 16 numbers. We start from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 14 and 15, right? So let's say 15 here. Okay, until 9 there's no problem, it's going to be the same number. 0 is 0, 1 is 1. It's like decimal to hexadecimal. So 0 is 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, 8 is 8, and 9 is 9. After 10 it's going to start with alphabet letters. 10 is going to be A, 11 is going to be B, 12 is going to be C, 13 is going to be D, 14 is going to be E, and 15 is going to be F. So this is a conversion from decimal to hexadecimal. Like this is how we translate a number from decimal number to hexadecimal number. Okay, now let's see some conversions. Let's see how we can convert this A to B base 16 to base 10. Converting base 10 is like, we look at the position, like the first position always power 0, 16 power 0, that's equal to 1, and the second position is 16 power 1, that's equal to 16, and the third position is 16 power 2, and that is equal to 256. Okay, now we look at the values in that position and multiply by them. So first we have 16 power 0, that's equal to 1. In 1 we have B, and if you look at B is equal to 11. So we will multiply this one by 11. And the second position is 16. In that one we have 2, so we multiply this one by 2. And the third position is 256. In that position we have A is equal to 10. So we multiply this one by 10. 256 times 10, that's going to be 2560. 16 times 2, that's equal to 32. 11 times 1, that's equal to 11. And if you add this 3 together, you are going to get 2603. Okay, so this is the conversion from hexadecimal to decimal. So this is base 10. 2603 is the conversion. Okay, now let's see how we can convert a number from hexadecimal to binary. So let's say they are asking to convert the same number in the hexadecimal A to B to convert into binary base 2. Let's see how we can do that. Now in order to do this one, the first thing is we have to convert this one into base 10. So base 10 we have seen how to convert that one, that's not a problem. So first we convert this one into base 10. So that's 2603, that's base 10. And the fundamental method is you divide this one by 2 until you get 0, and you put the values. Like you can watch my previous video, how did we do that. You can we divide this one by 2 until we get 0, and that's gonna give us a number of binary. And if you get that number, you will get 1101 and 01 and 1000 101. So this is the conversion from decimal to binary. So this is going to be the answer: 10100001 101011. So here the question is there any shortcut to convert this one? The answer is yes. If you look at this one here we have A to B. This is our hexadecimal number, and this is the table for hexadecimal. When we have hexadecimal, we can convert from this table directly. Like B is equal to what? B is equal to 11. If you look at 11, we have 1011. This is 1011, right? That's the first number. So we always go from 4 by 4 when we talk about hexadecimal. 2 is equivalent to 0010. 2 is A to B. This one is 0 0 1 0. Let me check. I made a mistake. 1 0 1 1. Yeah, this one should be 0. Okay, this one is 0 and this is, okay, I made a mistake right here. Let me rewrite this again. Okay, 1 1 0 1 0 1 0 0 0 1 0 0, and then we have 0 1 0 1. So this is the conversion. Okay, let's make sure this is correct. Now we have 2. If you look at 2 0 0 1 0, so this is the conversion, and a is equivalent to 10. 10 is equal to 1 0 1 0, so this is 1 0 1 0. So that's the correct answer. 1 0 1 0 0 0 1 0 1 0 1 1. Now let's see how did we get this number. So it's just easy to see from the table, but there's a logic to it. Now let's see how it is. So when we talk about binary, we say in another word we say 8421 for binary, right? Now if you look at this place, like we have, for hexadecimal we have 4 numbers, right? If you look at this place, in the 8th place we have 1, and in the 4th place we have 0. In the in the second place we have 1, and in the first place we have 1. And if you add this number, like 1 is here, 1 plus 2, just add the numbers where we have 1. 8 plus 2 is 10, 10 plus 1 11, 11 is equal to b. Okay, so 11 is equal to b. So you can do this for everything. Like here the second number is 2, so which number we have to have in order to have 2? That is, here you can see this one has to be 0 because that is 8. So this one has to be 0, and this one also has to be 0. Now we are left with 2. That's how we got this one. And a is equal to what? A is equal to 10, right? So in order to get 10, we always look at the highest number. Like 8, we have to have an 8 and 2. That's going to make that one 10. So we put 1 0 1 0. That's going to give us a 10. And that's the basic conversion of this one. Now let's see another example to do this. Okay, now let's get rid of this table. We don't need this table. We can directly do this like this method. Or we can compare with the table too. So let's keep this one for now. Let's get rid of this part. Okay. Okay, let's say we have a number that is AB73C5 and the base is 16, and we want to convert this one into base 2. Okay, now let's go ahead and do that. A is what? Okay, let's start from the backward. So 8421, this is what we have to look at. In order to get 5, what do we have to have? We have to have a 4 and a 1. So 0. Okay, let's directly write this here. Base 2. So we have to have a 4 and 1. So 0 1 0 1. Okay, and then we have to have C. C is 12. So we need an 8 and a 4. So 1 1 0 0. 1 1 0 0. 3. We need to have a 2 and 1. So that's going to be 0 0 1 1. And for 7, we need to have 4, 2 and a 1. That's going to make this one 7. So we have to have 0 1 1 1. And for B is equal to 11. We had to have 8 2 1. So 1 0 1 1. And for A, we had to have 10 8 and 2. So 1 0 1 0. We need some space. One zero 1 0. Now you can compare all these numbers with this table in order to make sure this is correct. Now 5 0 1 0 1. 5 0 1 0 1. This is correct. C C is equal to what? 12. 12 is equal to 1100. 1100. That's correct. 3 is equal to what? 0011. 0011. That's correct. 7 0111. That's correct. B, that's equal to 11. 11 is equal to 1011. That's correct. And A is equal to 10. Right? 10 is equal to 1010. So you can see how did we derive all these numbers, right? We don't even need a table. We just have to know 8421. Like when we talk about 16, base 16, that's 8421. And after that, it's easy. Now let's see what happens if we have base 8. For example, let's say we have a number 74321 and the base is 8, and we want to convert this one into binary. Now when we have base 16, we used 8421, right? But when we have base 8, we just use 3 numbers. 421. The 8 will go away. Like this is the number. Now we have to see what are the what are the 3 numbers that's gonna give us 1. This is the only one needed, right? So 001. 001. And what's gonna give us 2? 010. 010. What's gonna give us 3? 011. And what's gonna give us 4? 100. And what's gonna give us 7? That's gonna be all 3 numbers, so 111. And that's gonna be the base 2 of this octal number. Okay. Now let's see how we can go backward. Okay, let's say we have a number. Let's get rid of this one. Okay. Let's get rid of this one. Let's say we have a number in not decimal. Let's say we have a number in binary. So let's say this is the number 1101, 0111 and 1101. So this is the base 2, and we want to convert this one into hexadecimal. Let's see how we can do this. Same approach. Now we go backward. 8421. Previously what we did was we look at where should we put 10, but here we divide this one into 4. When we convert this one into hexadecimal, we divide everything by 4 numbers, and we look at the position. Like we have 18, this is, if I write this one in here, 1101, we have 181402 11. So 8 plus 4 2. We don't have any 2, so 8 plus 4 12, 12 plus 1, that's 13, right? 13 in the hexadecimal is equal to D. So we replace this one with, this is going to be D. Okay, we are converting to base 16. And 0111, this is 8 is 0 and 4 is 1. Let's get rid of this one to avoid confusion. 8 is 0, this 4 is 1, so that's going to be 7. 4, 2, 1, that's going to be 7. So here we are going to have 7 here. Okay, this is 7. And 1101, 1814 11. So 8 plus 4 12, 12 plus 1 13. Again, this is going to be D. Right? 1101, yeah, D. So this is going to be D7D. D7D. So that's going to be the conversion from binary to hexadecimal. Okay. Now let's see how we can convert a decimal point number. Okay, let's look at another example. Let's get rid of this one. Okay, so let's say we have a decimal point number, something like this: 101.11001.11001, and the base is 2. So let's see how we can convert this one into octal. So when we talk about octal, we know that this 8 will go away. We only have 3 numbers. Okay, so let's start from here. When we talk about octal, we just look at 3 numbers. So these three numbers 0 0 1, 4 is 0, 2 is 0, 1 is 1, so this is 1, and 1 0 1, that's gonna be 4 is 1 0, 4 is 1, 2 is 0, 1 is 1, so this is going to be 4 plus 1 5, and here we are going to have 4 plus 2 plus 1, that's going to be 7, and here we have ones. Okay, let me make sure I'm doing it correct. 0 0 1, 1 0 1, and then 1 1 1. Okay, let's put 1 0 1 here. Okay, it's okay, it can be any number, but it can be any number. Now for now I'm keeping this one as it is. Okay, so 1 0 1 1 is 4 and 0 is 2 and then 1 is 1, so that's going to be just 5. Okay, now let's look at here after decimal point. 1 1 0, that's equal to 4 plus 2 6, right? Now we have a problem right here. 0 1, we only have two numbers, but when we have two numbers in this side, we add a 0 right here. And same thing goes to, like before I put another number, but instead of that one I could have put 0 right here. For example, if you just have two numbers, you add another 0 and convert it. Here you can see I added another 0. Now you can see in the fourth place we have 0, in the second place we have 1, and this one we have 0, so this is going to be just 2, right? So this is going to be the conversion from binary to decimal, I mean binary to octal. We are talking about octal right now. So binary to octal is going to be 5751.62, because this is only for when we talk about three numbers, that's octal. When we talk about four numbers, 8421, that is hexadecimal. Okay, now let's see another example. Let's say we have a number, let's get rid of this one. Okay, let's say we have a number like this, AF3.E4C, and the base is 16, and let's see how we can convert this one into octal. Okay, in order to convert this one, what we do is, octal is base 8. Instead of the best way is to first convert this one into binary, then after that we can convert this one into octal. So binary is easy, as we seen before. When we convert hexadecimal to binary, we have to have 8421. So this one has to be 8421. Let's look at C. C is what? C is 12. So we had to have an 8 and 4. So 1 1 2 1 is going to be just 0. So 0 0. 4 we had to have just 4. 0 1 0 0. 0 1 0 0. E is equal to 14. So we need an 8 plus 4 12. 12 plus 2 14. So 1 1 1 0. 1 1 1 0. Point 3. We need a 2 and 1. So that's going to be 0 0 1 1. 0 0 1 1. And F is what? 15. 8 4, that's going to be 12. 12 plus 2 14. 40. So 1 1 1 1. Right? Because 12 plus 2 14. 14 plus 1, that's going to be 15. A is going to be 10. 8 plus 2. So 1 0 1 0. 1 0 1 0. So that's going to be the conversion. Now let's see how we can convert this one into octal. So when we talk about octal, we just look at 4 to 1. Okay, so 4 to 1. And when we talk about octal, we look at three numbers. So once, let's go from here, because when we go from decimal point, we have to be careful. We should start from here, because if we lack numbers, we have to add 0 and do the final one, right? So let's look at this one here. 0 1 1 1. 0 1 1. 4 is 0. 2 plus 1, that's going to be 3. So this is 3 and this is base2. Okay, 3 and 110 is 4 plus 2, 6 and 011 0 11, so 2 plus 1 3 and 101 is going to be 4 plus 1, that's going to be 5. Okay, here we have 111, that's going to be 7. 001, that's going to be just 1. 001, that's going to be just 1. 100, that's going to be just 4. So this is going to be the conversion. We are going to have 5363.7114, and that's how we do the conversions from hexadecimal to binary, binary to hexadecimal, and octal to binary, and octal hexadecimal to octal, and those kind of things. I hope this helps. Thanks for watching.